All right, for exponents and sets, these the laws we've done in grade 10. So every time a law pops up, I will just remind you of one. All right. We are going to solve for x by using both exponents and set interchangeably. All right. So the first problem there is 27 to the power of x squared plus x equals to 3 to the power of 3x squared times 9. So in instances like this, we try to have the same base because what we are trying to solve for is x, which is an exponent. So we're going to try to have the same base because we know that if bases are the same on the left-hand side and the right-hand side, then we're going to drop them. And is it possible? Yes. What is 27 in exponent form? You will see that on the right-hand side, the lowest base is 3. So we can try to make a 9 and 27 also base 3. So 27 is 3 to the power of 3. So we are able to change 27 and give it a base 3. So remember that is 27. Originally, we did have that x squared plus x. So we continue with it. Notice that I am putting that in a bracket because if you don't, then you might mistake 3 only multiplying with the x squared and not with the x. So the whole of 27 is 3 cubed. And then that cubed, the 3 has to multiply the rest of the exponent, which is x squared plus x. All right. And then on the right-hand side, we have 3. We can't change that to any exponent. 3 to the power of 3 x squared. And then 9. Is it possible to make 9 an exponential form with a base 3? Yes. 9 is 3 squared. 3 squared is 9. All right. So let's simplify further. So 3 times x squared will then give us 3x squared. And 3 times x will be 3x. Okay, this looks better already. So now the laws of exponents form, grade 10. We know that if the bases are the same, you see on the right-hand side, the bases are the same. That's base 3 and a base 3 with a multiplication in between. So if bases are the same with a multiplication in between, then we are required to add the exponents. If it was a division, we're going to subtract them. Okay, so it's going to be 3 to the power of, the base is 3, then we have to add our exponents. So we're going to have 3x squared plus 2. That is a law of exponent. If two bases are the same with a multiplication in between, we add the exponent. So this is what we wanted. So now we have one base, which is base 3 on the left-hand side. We have one base, which is base 3 on the right-hand side. So as soon as we have same bases on both sides, then we drop the bases and we are left with the exponent. So that was the aim, creating the same base so that we can drop it. You only drop a base if it's the same on the left and the right. So that means the exponents then are 3x squared plus 3x equals to 3x squared plus 2. All right. If we take this 3x squared to the right and to the left hand side, it's going to be 3x squared minus 3x squared, which will be a 0. Then we will be left with 3x is equals to 2, and then dividing both sides by 3 will then leave us with x being equals to 2 over 3. All right. Great. So the second one, now it's in a set form. Okay. At least with this one, the bases are already the same. We have base 2 on the left-hand side. We have base 2 on the right-hand side. Since bases are the same, we're just going to drop them. Remember, even if you have different bases, as soon as you get same exponent, you can drop the exponent and continue with the bases. But in this case, we have the same base, so we drop the base and we continue with the exponents. So we're going to drop the bases and we continue with x square root of x equals to 27. All right. So remember with set, if you have a set of A, okay, this will always be A to the power of 1 over 2. Okay. And what if there was a 2 here and a 5 here? Okay. If there's nothing, if A is to the power of 1 and then it's 1 outside there, then we know it's 1 over 2. But in this case, changing that set into an exponential form will be the exponent that is inside, which is 2 to the power of the number that's outside the set, which is 5. So 5 root A to the power of 2 will be A to the power of 2 over 5 in an exponential form. So that's how we transfer from a set to an exponent. But remember, if there is no number there and no number then the exponent is a half. All right. So with that knowledge, then what are we going to do to that square root of x or said x? All right. So we're going to have x. We want to change this set now and make it exponential. So it's going to be x to the power of, there's no exponent number, there's no number outside. So we know that that is a half to the power of 2. So we just change square root of x from a set form to an exponential form. All right. And then we have 27, which is 3 cubed in an exponential form. And then we continue. All right. So we have base x with a multiplication in between. These are being multiplied. Then we know the law says we need to add the exponent. So that means we're going to have x to the power of 1. It's a 1 if there's no number there. Plus a 2, 1 over 2, sorry. This is equals to 3 cubed. So we have x to the power of 1 plus a half will give us 3 over 2. Then we have 3 cubed. All right. Please notice that there is no way of making bases the same day. We have base x, base 3. There is no way we can change 3 and make it an x, or change x and make it a 3. We can't make bases the same. Same goes with the exponents. It's not possible now to make exponent 3 over 2 and exponent 3 the same. But we are not stuck. What we know is that you can multiply any number by its reciprocal in order to make it a 1. Remember, we are solving for x. So is there a way of getting rid of this fractional exponent there? Yes. Any number multiplied, any fraction multiplied by its reciprocal will give you a 1. What is the reciprocal of a over b? That would be b over a. You just exchange the fraction, make denominator numerator, and numerator you make it a denominator. So any fraction or any number multiplied by its reciprocal will give you a 1. And then what if we had 5? We will have to multiply it by 1 over 5. A reciprocal of 1 over 5 is 1 over 5, because this is the same as 5 over 1. Any number divided by 1 is that number. 10 divided by 1 is 10. 100 divided by 1 is 100. So, and this will give us a 1. So then, in this case, then, how do we get rid of this fraction? 3 over 2. We're going to multiply by its reciprocal so that we are left with only x on the left-hand side. The reciprocal of number 3 over 2 will then be 2 over 3. But remember, we just added something that was not on the equation to begin with. So we just destabilized that equation. To bring it back to balance, we need to do what we just did on the left-hand side through the right-hand side. All right. So we just introduced a fraction 2 over 3 in a power form. On the left-hand side, we're going to do the same on the right-hand side. We're also going to multiply the exponent that is on the right-hand side with fraction 2 over 3. All right, so 3 over 2 multiplied by 2 over 3 is a 1, and then yay, we are left with only x, which is what we wanted. 3 will cancel with 3. We are left with 3 squared. Therefore, x is equals to 9. All right, so for this one now, we are given that 5 to the power of minus x is equals to 10. So we have to find a way of using this given information on the expression. All right. So notice that even though the bases are the same, we cannot use laws of exponents. We can't add the exponents. That's because it's a plus in between, not a multiplication. So the laws of exponents only apply on a multiplication or a division. As soon as you come across a plus or a minus, then we take out a common factor. Okay, just keep that in mind. Okay, so because it's a plus, not multiplication, we're not adding the exponents. That law doesn't apply. We're going to take out a common factor. You will see that we have 2 to the power of x on the first term. We also have 2 to the power of x on the second term. So that means what's common between those two terms is 2 to the power of x. So we're going to take out 2 to the power of x out as a common factor. Then we will be left with 2 to the power of minus 1 plus 2 to the power of positive 1. Mm? 5 multiplied by, remember we are after 5 to the power of minus x. At this stage, we have 10 to the power of x, but that 10 can be changed. It can be 5 times 2. 5 times 2 is 10. And then this is to the power of x. I put it in a bracket because it was 10 to the power of x. So we still have to have 10 to the power of x. But 10 in this case is 5 times 2. So if you forget to put it in a bracket, that means you might mistakenly only have 2 to the power of x and forget to have 5 to the power of x as well. All right. Continuing. So now we have 2 to the power of x. And inside that bracket, we're going to have laws of exponents. 1 over 1 to the power of minus 1 is 1 over. To the power of minus 1, the laws of exponents says this is 1 over. So this will be 1 over 2. So it's a law of exponent that you need to know by head. Okay, so to the power of minus 1 means 1 over. So we're going to have plus 2 to the power of 1 is a 2 over 5 multiplied by 5 to the power of, so remember it's 5 to the power of x, 2 to the power of x, because it's a multiplication in between. We wouldn't have been able to do that if it was a plus or a minus. Not possible if it's a plus or minus. But because it's a multiplication, we can give 5 exponent x and we can also give 2 exponent x. So we have 5 to the power of x multiplied by 2 to the power of x. Remember that law of exponent again only applies on multiplication and division, not on plus or minus. All right. Then we have 2 to the power of x half plus 2 is 5 over 2 all over. Notice that we have 2 to the power of x divided by 2 to the power of x. That is 2 to the power of x minus x, which is 0. They disappear. So 2 to the power of x disappears. All right. And then we have 5. Okay, we no longer have 2 to the power of x here. So the numerator is half plus a 2, which is 5 over 2. Then the denominator is 5 multiplied by 5 to the power of x. But just remember, we were told that 5 to the power of minus x is equals to 10, not 5 to the power of positive x. That law of exponent 1 over. Okay, as soon as we say 1 over, then it will make it a positive, or we can just take this to the numerator. If it goes to the numerator, it's going to become a negative. All right, so that law helps us a lot. So we have 5 over 2. So I'm going to leave 5 in the denominator for now. And I am going to take 5 to the power of x in the numerator, because if it goes to the numerator, then the exponent becomes a negative. It changes sign. Okay. If you take that and you take it to the denominator, then it's going to change sign. It will be a positive exponent. Okay. Just keep that in mind. Okay. So now we have 5 over 2 multiplied by there. 5 to the power of minus x is equals to 10. That's the reason why I took this to the numerator, so that this becomes a negative. So 5 to the power of minus x is given to be 10. Then we have over 5. All right. So all of this will be equals to, so we're going to have 10 divided by 2 is 5. 5 times 5 is 25. And then 25 divided by 5 will give us a 5. Or you can just put it in a calculator. So the answer here is a 5. Okay, now for simplification, we are going to simplify this one. Okay, so that is a set plus a set, not multiplication. If it was a multiplication, we were just going to say 50 multiplied by 8. So that is a law of set. But because it's not a multiplication, we're not able to do that. So just like in exponents, if these things are separated by a plus or minus, then we're going to look for a common factor. But what common factor? We do not have common factor there. So this means that we have to create one. How do we go about that? Okay. In this case, we can be directed by this set 2 here and kind of see, is it possible to have a set 2 on the numerator? Yes, it is possible, because 50 is 25 multiplied by 2, and then 8 is the same as 4 multiplied by 2. So we still have 7 root 2. Okay, so this will take us to the square root of 25. We all know it's a 5. We do not have a square root of 2, so this will be 5. square root of 2. We are still respecting this plus. You'll see that we're only applying laws where there's a multiplication and a division. And then the square root of 4 is a 2. And then we do not have a square root of 2. So this is 2 square root of 2. So it's square root of 25 being 5, and the square root of 2 square root of 4 being 2, and then the square root of 2. And then we have 7 said 2 or square root of 2. Now we have a common factor. Square root of 2 square root of 2. Why am I looking for a common factor? That's because those two things are separated by a plus, not a multiplication. Very, very important. So the common factor is square root of 2. Then we are left with 5 plus 2. So we have 7 root 2. All right. Root 2 cancels with root 2 quite immediately. And then 5 plus 2 is a 7. So we're going to have 7 divided by 7, which is equals to 1. So the answer is 1 there. And then this side, how do we go about simplifying this? All right. Let's try to also make 16 in an exponential form, as well as that 81. We can also try to make it exponential form before we can deal with the outside exponent of minus 3 over 4. So I want us to do it last. Just consider it last. Deal with the inside first. All right. So in an exponential form with the lowest base, what could be 16? We know that 16 can be 4 squared, or it can be 2 to the power of 4. So it's always advisable to use the one with the lowest base. Okay. So instead of using 4 squared, we are going to use 2 to the power of 4, which is 16. Okay. Then we have x to the power of minus 5 over 6 over, and then 81 in an exponential form will be, let me see, 3 to the power of it's going to be 3 to the power of 4. So we are looking for the lowest base. You can still use 9 squared, but between 9 squared and 3 to the power of 4, the one with the lowest base is 3 to the power of 4. X to the power of, remember, if it's square root, changing square root to an exponential form is going to be to the power of half. That should be in your mind. You should know that in your sleep. All right. So all of this to the power of minus 3 over 4. Okay, we're still dealing with the inside. We will come back and deal with that outside exponent. Okay, so we have 2 to the power of 4 divided by 3 to the power of 4. And then with x, I'm treating it separately because the bases are the same with the division in between. So we know if the bases are the same with the division in between, then we're going to subtract the exponents. Okay, so we have base x, and then they are separated by division. So we're going to subtract the exponent. That's a law of exponent. So the exponents are 5 over 6 minus 1 over 2. All of this to the power of minus 3 over 4. So we will have 2 to the power of 4 over 3 to the power of 4 x to the power of, so minus 5 over 6. So I'm just putting it in a calculator. Minus 5 over 6. Then we have to minus 1 over 2. This will give us minus 4 over 3. Minus 4 over 3. So what we're now going to do is spread the outside exponent all over. All right, so that means then we're going to have 2 to the power of 4 multiplied by the outside exponent, which is minus 3 over 4. We are going to have 3 to the power of 4, that exponent multiplied by the outside exponent also, and the outside exponent is minus 3 over 4, and lastly x, which is to the power of minus 4 over 3. We also multiply it by the outside exponent, which is minus 3 over 4. So I was able to spread this exponent all over because all I have in that expression is multiplication and division. There is no plus, there is no minus, so no need for common factors. All right, so then we are going to end up with, okay, 2. Let me just write it here, we'll write it out. 2, 4 cancels with 4, then we are left with 2 to the power of minus 3. All over 4 cancels with 4, we are left with 3 to the power of minus 3. Then x, a number multiplied by its reciprocal, will then be equals to 1. All right, so we know, remember, to the power of minus, it's 1 over. So this is the same as 1 over 2 cubed. To the power of minus, it means 1 over. So this is 1 over 2 cubed. Notice now the cube is positive. And then this one will be 1 over 3 cubed. So that is a law of exponent. We know to the power of minus means 1 over. Then we have x to the power of minus 1, which is x. All right. So 1 over 2 cubed will be 1 over 8. 2 cubed is 8 over 1 over 3 cubed. 3 cubed is 27. X equals to, so 1 over 8 divided by 1 over 27 will give us 27 over 8x, and that cannot be more simple than that. So the answer is 27 over 8x. Okay, still on simplification. So with this one here, it's going to be easy to make that 4 base 2 and that 8 base 2. Those are the numbers that are commonly known. Okay, we're going to have 2 to the power of n plus 2. So just notice that we always try to have the same base everywhere. Okay, so we opting to make 2 base 2 because and 8 base 2 because all of them are able to have a base 2. So 4 in an exponential form will be 2 squared. Okay, then there's still n plus 1 over, and then 8 can be 2 to the power of 3. Exponent n minus 1. Okay, so this will be 2 to the power of n plus 2 multiplied by 2 to the power of 2 times n is 2n, 2 times 1 is 2. And then underneath we have 2 to the power of 2. 3 times n will give us 3n minus 3 times 1 will give us minus 3. So now the base is the same everywhere. On top multiplication, then there's a division. So we add the ones on top, which is multiplication, we're going to subtract the bottom. All right, because it's separated by a division. Okay, 2 to the power of, we are adding the exponents separated by multiplication. So it's n plus 2 plus 2n plus 2. Then we have to subtract what's divided. Okay, so that means it's going to be minus 3n plus 3. So that means it's just a matter of changing the signs of what's in the denominator because we subtracted it. Okay, so remember, when you subtract something, it changes its sign. Okay, so we have 2 to the power of n plus 2n is 3n. 3n minus 3n is 0. So n disappears. 2 plus 2 is 4. And then 4 plus 3 is 7. So 2 to the power of 7 is then equals to 128. The answer is 128. All right. So the next one is this one. We're still simplifying. So notice again now, we have a negative. So we are no longer able to kind of same base add the exponents or subtract the exponents. As soon as we see subtraction or addition, we take out a common factor. And right away, we notice that we do have a common factor, which is 2 to the power of x. 2 to the power of x. So we're going to take out a common factor, 2 to the power of x. Immediately when you see expressions that has terms that are separated by minus and addition, we take out a common factor. Okay, so we're not adding some exponents and dividing exponents. That only applies on division and multiplication. So here we are then left with 2 to the power of minus 3. 2 to the power of minus 3 minus, we have a 3 multiplied by 2 to the power of minus 1. 2 to the power of minus 1. All of this, 2 to the power of I'm going to make it 2 to the power of x multiplied by 2 to the power of minus 2. So the reason is because I want this to cancel. So remember, if bases are the same, we add the exponents, so you can also separate. So x minus 2 is the same as 2 to the power of x multiplied by 2 to the power of minus 2x. All right. And then 2 to the power of x, 2 to the power of minus x can cancel. And then remember again, 2 to the power of minus. That's 1 over. So in the numerator, then that means we have 1 over 2 to the power of 3. Okay, just remember that you'll meet with that quite a lot. Then we have 3 times, again, 2 to the power of minus. So this is the same as 1 over 2. Once again, we have 2 to the power of minus. So this will be 1 over 2 squared. So just remember, as soon as you say 1 over, then the exponents become a positive. All right. So numerator, what do we have? We have 1 over 2 cubed is 8 minus 3 times 1 over 2 is 3 over 2. At this stage, you can just use a calculator if your mind cannot calculate exponents or fractions. And then 1 over 2 squared is a 4. So you can put all of this in a calculator and just get an answer. And the answer is minus 11 over 2. Minus 11 over 2. All right, so the answer for that one was minus 11 over 2. All right, and then we're going to do the last one. So laws of exponents are quite, sets and exponents are quite versatile. You will see, like in almost every question paper, you see a different thing. Okay, so let's try to simplify this one. What can we do there? Okay, luckily it's a multiplication. There's a multiplication between those big sets. A dot is a multiplication. So just remember, there's a law. The laws of sets says if you have square root of a multiplied by square root of b, you can have one big square root and then a multiplied by b inside. That only applies for multiplication, not addition, not subtraction. If you have addition and subtraction, look out for common factor. Okay, let's do that. We're going to have one big square root and then multiply x plus root 2x minus 1 multiplied by x minus square root of 2x minus 1. Immediately I see difference of 2 squares. Difference of 2 squares. What is difference of 2 squares? If you have a squared minus b squared, you can make this a plus b, a minus b. A plus b, if you factorize the difference of 2 squared, it will always be a plus b, a minus b, provided that the a is a perfect square and the b is a perfect square. Okay, so this has a square root. Square root of a squared is a and square root of b squared is a b. So that means if it was an 8 here or 4, okay, let's have that. Instead of b squared, let's say maybe we had a 4. 4 is a perfect square. 4 is 2 squared. Okay, if you can represent it in something squared, then it's a perfect square. So it means we'd have a plus 2, a minus 2. So that is a difference of 2 squared if you look at it. So we're just going to write it backwards, return it to this form. All right. So it will be, okay, what are we going to have? X squared minus square root of 2x minus 1 squared. Okay, then we have x squared minus, so square root cancels with the square root in that case. Then we are left with 2x plus x. So just remember it's going to be this negative here. So negative times 2x will be minus 2x, and negative times negative 1 will be plus 1. Not x, sorry about that, plus 1. And that can be factorized, okay? If we factorize this, it's going to be x minus 1, x minus 1. We've also learned how to factorize. Okay, so this will be x times x, which is x squared, minus x minus x minus 2x plus 1. Minus 1 times minus 1 will be plus 1. So just notice that those are two brackets that look exactly the same. So we can just say x minus 1 squared instead of saying x minus 1 times x minus 1. Since it's two brackets that look exactly the same, we are able to just cancel one bracket and square the other. So we will just say x minus 1 squared. And then we know that square root will cancel with that 2 squared. And then the answer will be x minus 1. All right. So that is it for now.